Welcome to the BKR chemistry classes. Today let us see how to arrive at R bar S configuration. These configuration can be arrived based on the CIP nomenclature. So CIP nomenclature is nothing but Khan in gold prologue rules. So these rules will be used to assign R bar S configuration. So basically what do we need is the first thing which is required is a chiral carbon. The first thing required is a chiral carbon. So you need a carbon with four different substituents. So let us take it as A, B, C, and D. So you need four different substituents. For example, if I take CHO, OH, H, and Br. So now this particular carbon has four different substituents OH, aldehyde, hydrogen, and Br. So this particular carbon becomes a chiral carbon. So this particular carbon becomes a chiral carbon. So first you have to identify the chiral carbon. After identifying the chiral carbon, you have to assign priority. You have to assign priority. So the assign priority based on the atomic number. You have to assign priority based on the atomic number of what? Atomic number of the directly attached atom. Directly attached atom to the chiral carbon. You should not look for the atoms away from the chiral carbon. So the atoms which are directly attached, so in this particular case the directly attached atom are oxygen, carbon, Br, and hydrogen. So the atoms are carbon, oxygen, hydrogen, and Br. So you should assign the priority based on the directly attached atom. So now hydrogen has the highest atomic number, therefore first priority. Then comes oxygen, second priority. Then comes carbon, third priority. And the last is hydrogen, which gets the fourth priority. So now the second step is assigning priority based on atomic number. So you have assigned priority based on atomic number. Bromine gets the first priority. So it gets the first priority and H gets the last priority. So priority is given from 1, 2, 3 and 4. So four priorities. This is purely based on the atomic number. 1 is the highest atomic number and 4 is the lowest atomic number. So once this priority assignment is done, so you have prioritized the atoms attached around the carbon center. The third steps involves the sketching of a semicircle. Sketching of a semicircle. How should I sketch the semicircle? The semicircle should be sketched from 1 to 2 to 3. If this semicircle takes a clockwise rotation, it is known as R configuration. If the semicircle takes the anti-clockwise rotation, it is known as S configuration. Very simple. Clockwise means rectus, which means right hand side. Anti-clockwise means sinister, which means left hand side. So if your semicircle takes a right hand side clockwise rotation, it is R configuration. If the semicircle takes or traverse a left hand side or anti-clockwise rotation, it is known as sinister, which is S configuration. Done. But before drawing a semicircle and assigning the configuration, keep in mind that while assigning the configuration, the least priority group should be away from us. This is very important, or we say it to be far. So you should keep in mind that the least priority group should be away from us. Now, how to know whether the least priority is away from us or not? So when you write the Fisher form of a chiral carbon, you can see the horizontal bond and the vertical bond. Is it not? And the center is carbon. Okay, this is the chiral carbon here. So now this horizontal bond is known as near. So any group which is present in the horizontal bond are known as near groups. So B and C are known as near groups, and the groups which are attached to the vertical bonds are known as far groups. So these two are known as far groups. So what am I saying? So here B and C are known as near groups or atoms, and A and D are known as far groups. So if the priority is given as 1, 2, 3, and 4, as I told, the 1 is the highest priority and 4 is the lowest priority. The 4 priority group in the vertical should be in the vertical position. It doesn't matter if it is in the top position or bottom position, that doesn't matter, but it should be in the vertical line, it should be in the vertical position. So if your least priority is in vertical position, then the assigned configuration is correct configuration. So if you're assigning the R and S configuration, keeping the 4 priority in vertical position, the assignment is correct. But if you are assigning R bar as configuration, keeping your 4 in the horizontal line, then the configuration is wrong configuration. So what should do? I should try to change the position of the least priority from horizontal to vertical. So I should try to change the position of the least priority from horizontal to vertical. That may take some time. So no need of doing all such things. So what you do, whether your least priority is in vertical position or horizontal position, you assign the priority. So if I say that I have A, B, C, D, and A is first priority, B is second priority, C is third priority, D is fourth priority. So I'm drawing a semicircle. I'm drawing a semicircle from 1 to 2 to 3. So it is traversing a clockwise rotation. So clockwise, therefore it is having R configuration. And since the least priority group 4 is in the vertical position, the assigned configuration is correct. But if, for example, I have a situation like this: A, B, C, and D, and I've assigned the priorities 1, 2, 3, 4. So now we will do what you will do. You will draw a semicircle. You will draw a semicircle. So how will I draw a semicircle? I'll draw from 1 to 2 to 3. So 1 to 2 to 3, it again travels a clockwise. Is it not clockwise? Therefore, I'll say it to be R configuration. But what did I say? Keeping D in the horizontal position and assigning the configuration will be a wrong configuration. So what you should do is simply strike off the configuration which you have achieved and write the next configuration. Why? Because we have R or S. If R is wrong, obviously the S is the answer. So when you have the least priority in the horizontal position, need not change into vertical. Don't do steps to change it from horizontal to vertical position. No need of doing all such things. Whatever position, let it be in the horizontal position. Assign the configuration. So if it is in horizontal position, the assigned configuration is wrong. So write the next configuration, which is the S configuration. Finished. Very simple. This is the tip or trick. Okay. So generally, when you assign R bar as configuration, the least priority should be in vertical position. Whatever you assign will be right. But if it is in horizontal position, in this case, assign the configuration. Later, what you do is strike out the configuration, give the next configuration, which will be the right one. That's all. Finished. Very simple. Okay. If I have given a carbon like this in the wedged form, so this thick wedge is, we know that it is near to us, and the dashed wedge is away from us. So in such case, if I write it as A, B, C, D, you see from the side which is away from the least priority. So D is here, the least priority is here. So 1, 2, 3, 4. The least priority is away from us. So I should look from here. Suppose I have the eyes here. Don't mind the way I'm drawing the eyes. So I'm looking from here. I'm looking in such a way that the least priority is away from us. Now assign the priority 1, 2, 3. It travels a clockwise direction. Therefore, it is R. Very simple. Okay. Let me explain this taking a standard example. So I will give the example which already I had mentioned. Then we will do with some other problems. So I've taken this particular chiral carbon. Now assign the priority. We know the bromine has the first priority because it has the highest atomic number. So these are the directly attached atom, then comes the oxygen, third is carbon, and fourth is hydrogen. Now draw a semicircle from 1 to 2 to 3, 1 to 2 to 3. You can see that it is taking a semicircle which is anti-clockwise rotation. So the configuration is S configuration. But what did I say already? Whenever you assign a configuration, you should keep in mind that the least priority group should be away from us. So here the least priority is in the horizontal position, so which is near position. What should I do? I should strike out the arrived configuration and assign the next as the right one. So whenever you arrive at a configuration keeping the least priority in horizontal, whatever you get is a wrong answer, strike out that and give the next one as the right answer. So here the answer is our configuration. Very simple. Okay, let me take another example. So I am making it bit difficult for you people. So look at the directly attached atom. I have a bromine, I have a hydrogen, and here I have CH2, here I have CH2, here I have CH2, here I have CH2, I have an oxygen, CH2, and I have a CH3. So now the problem comes is I have a carbon here and I have a carbon here too. So, but they are different. They are different. Here I have CH2, CH2OH. I have a CH2 and OCH2, CH3. So they are different. They are different. So I have four different groups, but the directly attached atom both are carbon. Now, how to assign the priority? So when you are not able to assign priority at the first look, go beyond the bonds. So I have to traverse beyond the bonds. So this particular carbon is attached to two hydrogen and one carbon. One carbon. Now look into this hydrogen. So I have to travel further to find out the first point of difference. Keep that in mind. First point of difference. You have to look in for the first point of difference. Where you find the difference, assign the priority and move on. That's all. So here, this first carbon and this is also first carbon. They are not cannot be prioritize based on the atomic number because both are carbon. So I have to look go further. I go further bond. I see I have next carbon. So I see that this carbon is attached to two hydrogen and one carbon, whereas this carbon is attached to two hydrogen and one oxygen. So this carbon has two hydrogen and one oxygen. So I get the first point of difference. So here I have hydrogen, hydrogen, carbon. Here I have hydrogen, hydrogen, oxygen. So this is a point of difference. I have a carbon here. I have a oxygen here. So we know that oxygen has the highest atomic number, therefore this will get the highest priority. So this here bromine is first, this carbon will get the second priority, and this carbon will get the third priority. As usual, hydrogen has atomic number 1, which has the least priority. So I've assigned the priority. Now traverse a semicircle. Now traverse a semicircle. Okay, so it will go from 1 to 2 to 3. See, as I told, I should keep the least priority. So I'm looking from the front of the board. So I'm looking from the front of the board. So H is behind me. Okay, it's away from me. So 1, 2, 3 takes an anti-clockwise rotation. Therefore, it is S configuration. Let us take some more examples. Okay, now assign the priority. So you have oxygen, carbon, carbon, hydrogen. Again, I'm confused. Oxygen, I'll say 1 because it is higher atomic number than carbon, but I have 2 carbon here. Again, the same problem. Now, look into this carbon. This carbon is attached to 3 hydrogens. So, this carbon is attached to all the 3 hydrogens. But this carbon has 2 hydrogen further attached to another carbon. So as I told, if you're not able to find the difference in the first point, go beyond into the bond and look for the first point of difference. So what do I find here? I find that this carbon is attached to 3 hydrogens, whereas this carbon is attached to two hydrogen and one carbon. So I find the point of difference. I have hydrogen, hydrogen, hydrogen. I have hydrogen, hydrogen, carbon. I get the point of difference. Okay. So now this gets the second priority and this gets the third priority. So one, two, three. I get a semicircle which is anti-clockwise. So I say it to be yes. But what did I say already? H is in the horizontal position. So strike of the configuration. R is the right answer. Very simple. Okay. Another important concept. Suppose I have a group of this kind. I have a carboxylic acid. I have a methyl. I have an NH2. And I have an hydrogen. So you can see that here I have a carbon, here I have a carbon, nitrogen and hydrogen. So straight away I'll say nitrogen is first priority, hydrogen fourth priority without any reservation. Now I have two carbon. Now this carbon is attached to double bond OOH. Now whenever you have a double bond, C double bond, that means that the carbon is attached to two equivalent atoms, two equivalent oxygen atoms by a single bond. So the equivalence of double bond is it is attached to oxygen atoms by single bond. So that is the equivalence of C double bond O. Okay. So now as I can see, I have a carbon here. This carbon is attached to two oxygen and one more oxygen. So it is attached to three oxygen. So double bond O means it is attached to two equivalent atoms, two oxygen. So if I say I have C triple bond C, what does that mean? It means that carbon is attached to three carbon. And what about this carbon? This carbon is attached to again three carbon. So one, two, and three carbon. That is how you should consider a triple bond or a double bond. So if I say C triple bond N, that means that the carbon is attached to three nitrogens and the nitrogen is attached to three carbon. One, two, three. And carbon is attached to three nitrogen. That is how you should consider. So now I see here this carbon has attached to three oxygen and this carbon is attached to three hydrogen. So obviously we know that oxygen has higher priority than hydrogen. Therefore this gets the second priority and this gets the third priority. So now traverse a semicircle. Now traverse a semicircle. 1, 2, 3. 1, 2, 3 takes a clockwise direction. Therefore it is our configuration. Am I correct? Have I given the right configuration? Yes, because we see that the least priority is in the vertical position. So whatever you have given is the right answer. It's our configuration. So no doubt about it. Let us apply the concept which we have studied so far in solving JAM 2020 problem. The question asked is the amino acid with R configuration. The amino acid with R configuration. So now they've given four options A, B, C, D. Let us do one by one. The first option A, you have a chiral carbon attached to nitrogen, carbon, hydrogen, carbon. So obviously nitrogen first priority, hydrogen fourth priority, and now you have two carbon competing. So carbon here is attached to three oxygen, and this carbon is attached to hydrogen, hydrogen, carbon. So as I told already, if you are not able to identify the priority with the directly attached atom, go further beyond inside the molecule to find the first point of difference. So here you have carbon, here you have oxygen. Therefore, oxygen has the higher priority than carbon, or it has the highest atomic number. So you have the COH gets the second priority and the ethyl gets the third priority. So now traverse a semicircle. Now traverse a semicircle. 1, 2, 3. 1, 2, 3 takes a clockwise rotation. Clockwise, therefore it is R. So if you give the answer as R configuration, what you have given is a wrong answer, because already I've mentioned if you have the least priority in the horizontal position, whatever configuration you arrive is the wrong configuration. The second configuration is the right one. So this A has A's configuration, therefore A is the wrong answer. Now look into the B option. B has nitrogen, hydrogen, carbon, and carbon. Nitrogen first priority, hydrogen fourth priority. And now this carbon already we have seen O. So three oxygen, and now this carbon has hydrogen, hydrogen, sulfur. So don't do a mistake saying that here I have three oxygen, so 3 into 8 it is equal to 24. Here I have 1 plus 16 which is equal to 18. Don't do such blunder, never. So it is not a cumulative property. So here, as I told already, you should look for the first point of difference. Here you have oxygen, here you have sulfur. Sulfur has highest atomic number than oxygen. Even a one single sulfur will overtake or overpower the oxygen. So this carbon having even one sulfur will take the upper hand than the carbon containing three oxygen. Okay, so this will have the second priority and this carbon will take the third priority. So what is the point? We should look further into the carbon to get the first point of difference, and the first point of difference is this carbon has a sulfur and this carbon has the oxygen. Even single sulfur with highest atomic number will overpower the carbon with three oxygen. Okay, so we have this as second priority and third priority. Therefore 1 2 3 traverse a semicircle which is anti-clockwise, so you will give us S configuration. But since hydrogen is in the horizontal position, S is wrong, R is the right answer. So they have asked for R configuration and B is the right answer. B is the right answer. Let us quickly do the C and D option. So 1, 2, 3, 4. This is carbon attached to hydrogen, hydrogen, carbon of phenyl. This is carbon attached to oxygen, oxygen, oxygen. Obviously, three oxygen or even one oxygen will overpower the carbon. Therefore, 1, 2, 3 takes a clockwise semicircle. Since all hydrogen least priority is in the horizontal position, R is wrong, S is the answer here. C is wrong option. Option D, we have nitrogen, carbon, carbon, hydrogen. See, they have given a point of confusion here, they've given a sulfur here, but you have to look in for the first point of difference. So this particular carbon has hydrogen, hydrogen, and carbon. But this carbon has oxygen, oxygen, oxygen. So first point of difference is here you have a carbon, here you have an oxygen. So this will take an upper hand than this carbon. Okay, so oxygen is having higher atomic number than carbon, therefore this nitrogen has the first priority, carboxylic acid will have the second priority, and this carbon containing the ch2 ch2 SCH2 will get the third priority, hydrogen 4. So 1 2 3 takes a semicircle which is clockwise, but since hydrogen is in the horizontal position, whatever you get is wrong, so S is the answer here. Okay, so S is not asked, so they've asked for R configuration, so the right answer is option B. Hope you have understood this particular video. If you want me to discuss some more problems or you want me to discuss some other concept, kindly post that in the comment section. If you want me to discuss some other topic, that also can be posted in the comment section. Kindly like, share and subscribe the video. Thank you so much.